Welcome you all for the lecture series in industrial robotics. So, introduction to robot kinematics. The today's topic is the study of motion and position analysis of robotic systems. So, all the robotic systems have autonomous mobility to identify where exactly the end effector is and where it has to be seen is being analyzed in this kinematics. So it involves understanding the way robots move in the environment and how their parts are connected to achieve their specific tasks. What are the types of robot kinematics we have? One is forward kinematics, inverse kinematics, differential kinematics, and Jacobian matrix. So in forward kinematics, it determines the position and orientation of the end effector based on the joint angles. In inverse kinematics, it calculates the joint angles are required to achieve a desired end effector position. Differential kinematics describes the relations between joint velocities and end effector velocities. Jacobian matrix, it represents the mapping between joint space and the velocity of the end effector. So forward kinematics is the process of calculating the position and the orientation of the end effector of a robot with respect to robot's base frame. It involves determining the joint angles and the relationship between individual links in the robot's arm. Applications used in robotics, animation, and virtual reality to predict the movement of robotic systems. So in the inverse kinematics, it is determining the joint parameters that achieve a desired end effector position and orientation. More challenging than forward kinematics due to multiple solutions and singularities used in 3D animation, biomechanics, and virtual reality simulations. So differential kinematics deals with the relationship between the joint velocities and the end effector velocity of a robot. It enables the analysis of how changes in the joint positions affects the robot's movement. Understanding differential kinematics is crucial for controlling the motion of robots with multiple degrees of freedom. So the Jacobian matrix represents the relationship between joint velocities and end effector velocities. It is crucial for understanding robots' behavior in various tasks and environment. So what are the workspace analysis in robot kinematics is ergonomics, efficiency optimization, reachability analysis. Ergonomics is evaluating workspace ergonomics for optimal robot movement and efficiency. Analyzing workspace to optimize robot movement and minimize energy consumption. Assessing robot arm reachability within the workspace for task execution. Singularities in kinematics is position singularity, orientation singularity, and workspace singularity. We have three singularities. Robot arm loses dexterity, that is position singularity. Limitation in rotational movement is orientation singularity. Workspace singularity is restricted reachable access for the areas. So what are the major applications of robot kinematics is, one is manufacturing automation. Robot kinematics are used in industrial automation for tasks such as assembly and welding. Medical robotics, precision movement in surgical robots on advanced kinematic principles for safe and effective procedures. Space exploration is nothing but robot arms and manipulators in space missions use kinematic concepts to handle delicate equipment. Because in this, if you see in the space exploration, the parts are very delicate because there is no gravity and it is not rigidly had a ground support. So there is a possibility of damage of all the delicate components that is available in the space. So precise movements in surgical robots rely on advanced kinematic principles because a robot arm is expected to make surgery, which is safe and effective procedures. So it should rely on advanced kinematic principles for safe and effective procedure. So thank you.